All right, guys. So we'll go ahead and get started. We're gonna cover sections 11.1 through 11.4, kind of just a brief overview of some basic probability stuff. Today's lesson, we don't really get into probability, more so like counting, ways to count big sample spaces. Talking about permutations and combinations. You have heard about this stuff before, like probably in pre-algebra, but it's been a long time. So if some of this stuff seems familiar, it should. Hopefully that helps as we go through it. So one way to count, quickly is to use this fundamental counting principle. So it allows us to count large numbers of possibilities quickly. So an example that they give us in this key concept is, if we have 3 pairs of pants to choose from and 2 shirts, that probably means we need to go shopping, right? No, just kidding. But there are, how many ways could we make the outfits? That'd be 3 times 2 equals 6, okay? And that's nothing new, but that's the counting principle. So let's do an example or two. So example 1, a college offers 3 different English courses, 5 math, 2 art, 4 history courses. How many ways can a student choose one of each type of course? So in this case, we'd be filling 1, 2, 3, 4 spots, right? And then just how many ways do we have to fill each spot? So we have 3 choices for English, times 5 for math, times 2 for art, times 4 for history. Then you just, punch that into your calculator, and that would be 120 possible ways to do that. So nothing too terribly difficult about that. And then one more example before we move on to bigger and better things. Example 2. Below is an example of a Maryland license plate from 2004 and 1912. How many more of the more modern plate are there? Okay, so I think just for your notes, it says were possible then 119 style plates. That should be what should that say? I think 1912. 1912 is what that should say. Okay, so basically our layout for the more modern plate is 3 letters followed by 3 digits. And then in 1912, they just had 4 digits. Okay, everything else was fixed. How many letters? So kind of going spot by spot, 1, 2, 3 spots. How many letters options are there? How many letters in the alphabet? Andrew? 26, right? So basically to fill that first box, we would have 26 times 26 times 26 ways. I'll just write 26 to the 3rd power. And then that second box, we have, 1, 2, 3 digits, right? So how many options do we have for digits? Think about a keypad on a phone, right? So there'd be what, 10, right? So 0 through 9 would give us 10. So we'd have 10 to the 3rd power ways to do that. So that's going to be a lot of possibilities, right? And let's go ahead. It says how many more than the old plate. So we're going to subtract from that the number of ways to do the old plate, which just had 1, 2, 3, 4 digits. So there'd be 10 to the 4th power ways to do that. Obviously, we'll need a calculator for that. So we'll do 26 to the 3rd times 10 to the 3rd. And then that would be the number of possibilities we have on the 1912 plate, or sorry, the 2004 plate. And we're going to subtract from that the 1912 possibilities, which would be 10 to the 4th. And so that's going to give me 175,660,000. So over 17 million more possibilities, which, if you think about it, that makes sense because there were a lot fewer drivers back then, right? So that would make sense that we would need more plate options now. Okay, so going to example 3 then. Anybody know how to read what it says on A? And the answer is not 5. Anybody know what that says? Anybody know? Nobody knows what that is? 5 factorial, that's right. So anybody know what that means? 5 factorial? That's right. Yeah. So it's like, so yeah, 5 times 4 times 3 times 2, and technically times 1, but we don't really need to type that in, right? So that would be 5 times 4 times 3 times 2 is 120. All right, now what about if I give you a little bit tougher problem there? 12 factorial over 10 factorial. So that is basically going to be, and I'm going to just write all that out to give you, let you see what happens. Running out of space there. And then so 12 all the way down to 2, you could write the 1, but then divided by 10, 9, and I'm just going to do dot, dot, dot there. Okay, so what would happen there is the whole, these would cancel these, and we'd basically be left with 12 times 11 over 1. Okay, is all it would be. And 12 times 11 is 132. There at the end, but just try it. I won't call on you or anything, but I'll give you a chance to answer if you want. What would 11 factorial divided by 7 factorial times 2 factorial be? Take a minute, try to do that, or at least get as far as you can. Do what? That's right. That's right. You like that. Math jokes are always good, I had to wake you guys up. Right, still rolling. Okay, so I kind of showed you how you could make some cancellations there, and basically we end up with, the only thing we would really have to type in is 11 times 10 times 9 times 4 should be it, so 3,960. Now, before we move on, there may be an even easier way to type this in, and I'm going to go over that, and then we'll move on. Okay, so without even canceling, doing this less so by hand and more using our calculator. This is how we can take a shortcut on our calculator here. So everything you need for probability, all these symbols is under math, and then the one that says PROB. So if I want to type in 11 factorial like it looks on the paper, I can't. So I'm going to type in 11, go to math, over to prob, and then you see the factorial symbol is option 4. So I have that entered. Now I'll just do divided by. Now we do have to be a little bit careful with the denominator. You'll want to, if you want to type it in like it looks, you'll want to group that in parentheses, okay, as far as your calculator goes. So I'm going to do parentheses first, and then 7 math, go over to probability, option 4, and then times 2 is all the next thing is. So I'm just going to type a 2. So it looks just like that. And there I get the same number, right? So there's a little bit of a shortcut there for you. And I'll show that again before we're done. All right, so anyways, anybody have any questions so far? All right, so now we'll get into the big stuff, the permutations and the combinations. So a permutation is an arrangement of terms in a, and here's what you need to like highlight. This is the big part. It's in a particular order, so like a race or something. Order matters. Okay, so this would be a case of saying like you know, a good permutation problem would say, all right, I'm going to take U10 in this column here, and I'm going to say, you know, go race a quarter mile around the track. How many ways could you all finish top 3, right? So order would matter, right? It would be a different outcome if Cohen finished first or if Cohen finished third, right? That'd be a different outcome. So anyways, there is this formula. Show you an example here. Again, think about the example I just used. If we have 10 people that could finish top 4, this is how we can do that. So you do 10 factorial over 6 factorial, which basically a shortcut for that would be this. If you think about the way they cancel out, that would just be 10 times 9 times 8 times 7. So you just kind of you start with 10 factorial, but only go out 4 spots. Okay, that's how you do these by hand. All right. So again, if we want to do it by hand, go ahead and flip over. Yeah. So 12P8 is going to look a lot like 12 factorial, but we're only going to go out 8 positions. So 12, 11, 10, 9, 8, 7, 6. Let's see. 1, 2, 3, 4, 5, 6, 7. All right. So one more. So all the way down to 5. The rest would cancel. And so then we could just type that in. 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5. And that would give you 199,584,00. 199,584,00, which is like close to 20 million. All right, and then if I wanted to do B, kind of by hand, so to speak, that would be 20 times 19 times 18 times 17 times 16. Again, looks like 20 factorial, but we only go out 5 positions. And so 20 times 19, 18 times 17 times 16 is 186,0480. So close to 2 million. Now, as you might have guessed, there is a shortcut for this in your calculator as well. You might have noticed something that said NPR when we were in the probability space on our calculator. So here's how you can type that in without having to type all the, you know, we would want kind of a shortcut on this one, right? That's a lot to type in where we could mess up. So let's look at 12P8, right? So what you want to do is type the 12 first. Then you can go to math, over to probability, and then you want option 2, okay, NPR, and so far it looks like this, and then we can type in the 8, and we get that same number we did when we typed it in the other way. Okay, so there's a shortcut there. All right, so let's look at a few of the word problems. Most of your, if you do the Math Excel, most of it is these word problems. So how many ways can 5 Scrabble tiles be placed in a row? So that would just be, anytime we're arranging, 5 things in a row, that would just be 5p5. So really that's just 5 factorial, which we've already gone over how to type that in. So taking some shortcuts here, saving some time, that's going to end up being 120. A problem that's probably more like a test problem is going to be like example 6 here. So, a drama club has 20 members, and how many ways can you choose a president, vice president, and secretary, right? So we kind of have 20 to choose from in the group. Order matter because there's a different title for every spot, so it's a permutation, and then we're filling 1, 2, 3 positions, right? So it's going to be 20p3. And again, that probably would be just as easy to type 20 times 19 times 18 than 20p3. But either way, I'll give you a second to type it in. You should get 6,840. 6,840. All right. So now on the next one, I'm going to give you a chance to type in what you think you should type in. If you do it right, your calculator is going to give you a number in scientific notation, which is fine. But just see what you can do, and I'll go over how we would write that down or interpret it, because sometimes that can be a little confusing. So, big thing is, do you know how to set it up? Don't worry about example 8 because that's something a little bit tricky about that one. Try that again. All right, so should have done 35 P8 or 35 times 34 times 33 all the way out 8 positions. So this is a lot easier. When you get that number right there, that just means that decimal times 10 to the 11th, if you didn't know that. So we'll call that about 9.49 times 10 to the 11th. All right. Okay, so let's look at example 8 and then 9. So how are those kind of different? So it says in the little text box there, if you are assigning position to things and some of the items are identical, basically this kind of gets us into combinations where we start to take out the repeats. So what we do is, kind of just do like this. All right, if we were arranging the words happy, we would just do 5 factorial, right? Because there are 5 of them. But then what you want to do is take out anything that kind of repeats. All right, so there are 2 P's, right? Those are my repeats. So we would want to divide that by 2 factorial. So basically that cuts our possibilities in half. 5 factorial would be 120. If we divide that by 2, that takes us down to 60. Okay, so then what if we look at Mississippi? Let's think through that one together real quick. First of all, if there were no repeats, how many letters am I working with? 11, good. So if there were no repeats, it would just be that. So then we'll try to divide that by any repeats, right? So we have several. So how many I's are there? Has anybody counted those? 4 I's. All right. What about S's? How many S's are there? 4 S's. Anything else repeat? P's. How many P's? 2. All right. Very good. All right. So then we want to divide all that out. So we're going to divide that by 4 factorial times 4 factorial times 2 factorial. So we're going to divide out a lot of repeats here. I'm going to give you a chance to type that in real quick because that could be tricky. And remember, if you are going to type it in using factorial, you're going to want to put the bottom in parentheses. So I'll do that while you're doing it. All right, so anyway, should look something like that. You don't really need the factorial symbol after the 2 because that would just make it 2 times 1 instead of 2. So I just typed my denominator is 4 factorial times 4 factorial times 2. And then that gives me 34,650. All right, so I know we're kind of moving through a lot today, but tomorrow's notes are really short. So if you have questions over any of today's, we can ask, tomorrow too. So the last idea is a combination. A combination, like a permutation, is an arrangement. But the difference is that's where order doesn't matter, okay? So remember my general example I gave would be like a race where order does matter. This word problem you might see on this one is you're going to order a pizza from Arnie's. They have 12 toppings to choose from. How many ways can you randomly choose 4, right? So it doesn't matter, if they put the pepperonis on first or third, they're still on the pizza, right? So order doesn't matter with these. There is this formula you can use, but I'm not even going to worry about showing this by hand. We're just gonna use the shortcut. Okay. Yeah, I won't. Yeah, we'll just use the shortcut. So we'll just type this into our calculator and not really worry about how it works by hand because we're a little bit low on time anyways. So 15C3. So we'll type the 15 first. Go to math, probability. And then you want NCR, so option 3. And then 15 choose 3, so we'll put 3 in. So it looks just like it does on the paper there. And that'd be 455. On the filled out notes, I do show this with the formula, but just to save time, we'll jump right to it. So then 12 choose 9. Give you a chance if you want to try to type that in real quick, and then we'll do a word problem or 2 and call it a day. All right, so 12C9 is going to be, for all those of you who typed it in, should be 220, 220. Anybody need to see that up on the board? All right, so how do I set these up from a word problem then? So basically, it's pretty easy once you decide if it's a permutation or a combination because the bigger number always goes on the left side, right? The smaller number goes on the right side, okay? So in how many ways can you select 3 tiles from a set of 5? So 5 would be your big number. It's a combination because order doesn't matter. And then 3 goes here, right? So this would be 5C3. which again, just so I've shown it more than once, type the 5, go to probability, looking for NCR, bless you, that's option 3, and then type in the 3. So 5C3 is going to be 10. 10 ways we could do that. All right, and if you want to try the last one, I'll put it up here in just a second. Then we'll call it a day for math. All right, so 10C3 is how you should have typed it in, and that ends up being 120 possible combinations, okay? So we'll go ahead and wrap it up there. I think I got this whole lesson, so I'll attach